Okay, welcome to the third video on permutations and combinations. I've done two categories of questions with you. One that was based on just combinations, and the second one now, which is based, the second one, which was based on permutations of letters. Now, the third category that I'm talking about today is permutations of digits. You can have questions where you will be asked to, sort of tell the examiner how many digits of how many different numbers you could create with the digits that you are given. Okay, they work in mostly the same way that letters did. There is a slight difference in the workings that I'll do. What I will now encourage you to do is that whenever you come across permutations and combinations questions, you should see which category it falls into. Okay, so let's start. It says a four-digit number is formed by using four of the seven digits 1, 3, 4, 5, 7, 8, and 9. No digit can be used more than once in any other one number. Find how many different four-digit numbers can be formed if there are no restrictions. Okay, now remember that how is this different from letters? Usually what happened was that the number of letters that I had was equals to the number of dashes that I was putting, but in this case that's different. Okay, I don't have nine dashes. Sorry, not nine. One, two, three, four, five, six, seven. Okay, I have seven numbers, but I am constructing four-digit numbers. I find how many four-digit numbers. Okay, so that is the idea here, that what I'm going to do now is that I will have to fill in out these four dashes based on the numbers that I have. Okay, now in this case, whenever you have more um, digits than the number of places that you have, you sort of mix together permutations and combinations. So what I'm going to do here is I'm going to use combinations to fill those dashes. How will I do this? This will always be true about questions where you have to construct numbers. What I'm going to say is that you have about one, two, three, four, five, six, seven numbers available. So you're going to say that in order to fill this first dash that I have here, there are seven C1 choices. For the first dash, I have seven C1 choices. When I filled out this first dash, I have six C1 choices. And then for the next one, I have five C1 choices. And for the last one, I have four C1 choices. So I'm going to fill out each dash individually. When am I going to do this? I'm going to do this when the number of digits that I have is less than the number of uh, is more than the number of dashes that I have. Okay, if this was a letters question and I had more letters and I wanted to organize less letters, I would have done the exact same thing. Okay, 7C1 is basically 7, 6C1 is 6, 7, 6, 5, and 4 give me 840. So in making these choices individually for each of these dashes, I have come up with the number of possibilities that are going to be there for the entire number. Okay, let's look at part 2. It says the number is less than 4000. So I put down four dashes. Now there are some restrictions. I don't just want any number. I want a restricted set of numbers that are less than 4000, which means that the number can't start with 5, it can't start with 6. There is no 6 though. It can't start with 7, and it can't start with 8, and it can't start with 9. It has to be less than 4000. So there are limited possibilities for the first space that you have here. So I'm going to first write down that this dash above can have the numbers 1 and 3. There's no 2 as well. Okay, so it can only start with 1 and 3. So for the first dash, you have two C1 choices. Okay, so you selected one number for the first dash, you fill out the restriction first. There's no other restriction involved. So you're going to say that there were a total of seven numbers. One of those numbers got settled on the first space that you have, not two numbers. One of the numbers is going to get chosen because you just selected 2C1, so you're left with six other numbers. So six other numbers, five other numbers, and four other numbers. Okay, one settled down on the first dash, and the others are there in front of you. So that gives me a total of 240. So whenever you have a numbers question, that is how you do it. When the number of digits that you have available is more than the number of digits that you have to select, some people will solve it with NPR. I'm also absolutely fine with that. If you want to do that, I generally don't teach NPR. Okay, part 3. The number is even and less than 4000. So there are now two restrictions. How do you determine an even number? Based on the last digit that you have. So there are two possibilities for the last digit, 4 and 8. And it has to be less than 4000, so 1 and 3. Now these restrictions are not overlapping. We'll talk about that later on. There are two C1 choices here and two C1 choices here. Okay. I had two C1 choices for the first dash and two C1 choices for the last dash. Now a total of 7 numbers were there. Two of the dashes have gotten filled. Okay, either 1 and 3 or 4 and 8 got filled. Okay, how many are left over? 5 are left over. So 5C1 into 4C1. Okay, let's see what we get. 20 into 4 is 80. Yeah. Okay, that is the correct answer. That forms the basis of the questions that I'm going to do in this video for you. Please make sure you watch the entire video carefully. Look at the next one. It says a 4-digit number is formed by using 4 of the 7 digits 2, 3, 4, 5, 6, 7, and 8. No digit can be used more than once in any number. Find how many different 4-digit numbers can be formed if there are no restrictions. Okay, if there are no restrictions. So 4-digit numbers, how many digits are available? 1, 2, 3, 4, 5, 6, 7. 7 numbers. So 7C1 into 6C1 into 5C1 into 4C1. That gives me a total of 840. Part 2, the number is even. So for even, I just have restrictions on the last dash. It's 2, 4, 6, and 8. So there are 4 possibilities for this last dash. Okay. Out of 7 numbers, remember that you always fill out the restrictions first. So if one number got settled at the end, how many out of 7 were left? 6 were left. I start from the first dash, 6C1, 5C1, and 4C1. 6 into 5 into 4 into 4 gives me 480. Moving on to the next one now. It says calculate the number of different 6-digit numbers which can be formed using the digits 0, 1, 2, 3, 4, and 5 without repetition and assuming that a number cannot begin with 0. Okay, so calculate the number of different 6-digit numbers. I'm going to put out 6 dashes. The number of digits available is also equal, so I could use that too. But digits are useful when you sort of put out dashes and then try to fill out the restrictions that you have without sort of distorting the process. Okay, let's look at this. It says assuming that a number cannot begin with 0. So the possibilities for the first dash are 1, 2, 3, 4, and 5. Are there any other restrictions? No, there are no other restrictions. So I'm going to say that this is 5C1. How many numbers were there in total? There were 6 numbers. One got filled, so 5 were left. So another 5C1, then a 4C1, then a 3C1, then a 2C1, and a 1C1. Okay, what does that give me? Remember that 4C1 is 4, 3C1 is 3, and so on. If you remember that. I get a total of 600. Okay. Taking you to the next question. It says the digits of the numbers 1, 2, 4, 4, 6, 8, 7 can be arranged to give many different 7-digit numbers. How many of these 7-digit numbers are even? Okay, now remember that with even, what you have to be careful about is this double counting of 4. Okay, you will end up with trouble if you don't notice that. So let's put out first 7 digits. Okay, so for even, you can have a 2 here, a 4 here, a 6 here, or an 8 here. I'm not writing two fours because ending with the first 4 or the second 4 is the same thing. You cannot have a different combination for that. So what I'm going to say is that one of these numbers is going to settle here. Now, with identical numbers, you have to be careful. You see, this is a 4-mark question, and this is the reason it's a 4-mark question is that it has to be thought about first before it can be attempted. Whenever you have repeated digits as well, remember that you will have to sometimes fix them in positions before you can go on and calculate the remaining possibilities. Okay, now if remember that if the 2 comes up here, if I have a 2 here, there will be two 4s that are going around in these places. Okay, there will be two 4s, so there will be double counting happening. So what I'm going to do is I'm going to separate the 4s. I'm going to say that I have two cases, one that ends in a 4 and one that does not end in a 4. One that does not end in a 4 will have this problem, and I'm going to tell you how to solve this problem. Firstly, there are 3C1 choices here. There were a total of 7 numbers, so one went away. Therefore, 6, 5, 4, 3, 2, and 1. Okay, but what I'm going to say is that this becomes 6 into 5 into 4 into 3 into 2 into 1 into 3C1, which is 3, divided by 2 factorial. Remember that whenever you had identical things, you would divide. Okay, so that's what I'm doing here as well, because those two 4s were getting arranged in the middle. I will say that this is what's happening. Then the other case where you have only one 4 at the end, so I'm going to say that this is 1C1, 6C1, 5C1, 4C1, 3C1, 2C1, and 1C1. So this is just going to be 6 into 5 into 4 into 3 into 2 into 1. Now, this case might be solved in a simpler setup as well, but I'm just building up for the late questions later on. Remember that you will have to do this. Let's say there were two 4s instead of one 4. So you would have to first fix 2 at the end, then fix 4 at the end, and solve like the ones like I have in this case. You will then have multiple cases. Okay, so 6 into 5 into 4 into 3 into 2 into 1 gives me 720 here. And it gives me 1080 here. So total becomes 1800. Okay, taking you to the next question. Now it says find how many different numbers between 20,000 and 30,000. Now I have very specific numbers that I want to find out. So I put down my dashes. They are going to be 5-digit numbers because between 20,000 and 30,000, I cannot have more digits available than there. Okay, so between 20,000 and 30,000, so I know that the only number that can come up here is 2, so that's 1C1 choice. Okay, there are no other restrictions. There were 6 numbers that were available to me, so I'm going to say 1C1 and then 5C1 because 1 got selected, 4C1, 3C1, and 2C1. That gives me a total of 120. Okay, let's look at these last two questions that we have, and there will be something very specific in these questions that I want you to note. It says find how many four-digit numbers can be made using only the digits 1, 3, 5, and 6 with no digit being repeated. I think that's fairly simple. You've done that repeatedly. You'll say 4C1, 3C1, 2C1, and 1C1. That gives me 24. But how many different odd numbers greater than 500 can be made using some or all of the digits 1, 3, 5, and 6 with no digit being repeated? Now remember that there are two kinds of restrictions. One is that I want the numbers to be greater than 500, and the other that I want them to be um, odd numbers. So the first thing that you have to decide is how many dashes to put. If you put down 4 dashes, what you've inherently ignored is that the number could also be a 3-digit number greater than 500. There are actually two possibilities, one with 3 digits and one with 4 digits. Let's talk about the one with 3 digits. Since the number has to be greater than 5,000, there are two things that can happen here. There could be a 5 or a 6. And if it has to be an odd number, it could be a 1, 3, and 5. Okay, let's first talk about this possibility. It's very important. It's a 4-mark part, and there's something very specific about this question. What is specific about this is that it has a set of overlapping restrictions. That 5 could appear on the first position and it could also appear on the last position. When you have such a case of overlapping restrictions, what you need to form is cases. What do you do in those cases? You pick up one set of restrictions and you try to fix them rather than keep them as choices. Okay, so what I'm going to do is I'm going to create two cases, one with a 5 fixed and the other with a 6 fixed. When a 5 is fixed on the first position, the choices that I'm left with are 1 and 3. When a 6 is fixed on the first position, the choices that I'm left with are 1, 3, and 5 on this position. Now let's fill out. This is 1C1. There are no other choices there. Let's fill out the restriction first. That's another 2C1. So two numbers got filled. One is on the first dash and the second is got filled on the last dash. How many numbers did I have in total? I had 4 numbers in total. So I'm going to say that I'm left with 2 numbers now. So that's 2C1. I'm going to calculate that. That gives me 4. And again 1C1 and then 3C1. And this time I have again 2C1. Why? Because there were 4 numbers in total. One got filled in the first, one got filled in the last, and the center one was 2C1. So that gives me 6. Then let's talk about the 4-digit numbers. What I was fixated on that the number had to be greater than 500. So all 4-digit numbers are greater than 500. That's not a problem. So this first digit does not even have a restriction. The only restriction is this last one, 1, 3, and 5. So 3C1 choices. How many numbers did I have in total? I had 4 numbers in total. So out of 4, 1 went away. So 3C1 choices, 2C1 choices, and 1C1 choices. So what do I have? I have 3 into 2 into 6 into 3 is 18. So I have 18 plus 4 plus 6. That gives me 28. Okay, so pretty detailed question. Please understand the concept of overlapping restrictions. Let's say then 6 cards numbered 1, 2, 3, 4 are arranged in a line. Find the probability that the card numbers 4 and 5 are not next to each other. When you want something not next to each other, there are two ways of doing it. Specifically, when there is a probability question, what I would suggest is doing this 1 minus probability of together. Now, in the past, you've done together in alphabets. It's pretty much the same in letters and digits. What we did was right now make dashes and do it. So I'm still going to do that. But now I'm not going to write down choices. I'm just going to do letters because those letters are not, those digits are also not identical. So I don't have to worry about all of that. Okay. So for together, you subtract, you keep 4 and 5 together. Okay, and you put the remaining dashes outside, those are 4. So the box is the dash. But now I'm talking about probability. Remember that when you're talking about probability, there has to be a denominator. What is the denominator? The denominator is a set of unrestricted outcomes. So let's say I make it on the side and say there were unrestricted outcomes about 6C1, 5C1. So 5C1 and then 4C1 and 3C1 and 2C1 and 1C1. Since there were no restrictions, I'm going to say that the denominator that I have here is 6 into 5 into 4 into 3 into 2, or 6 factorial simply. Okay, so 6 factorial. Let's talk about the numerator, 5 dashes. So 5 factorial, 4 dashes in a box, 5 factorial, and then inside the box is 2 factorial. Okay, let's see if we get the correct answer here. What's 5 factorial? 1 minus answer. Yes, I am getting 2 over 3. Let's look at the last question in this video. I will be back with another video for the last part of this topic. It says find how many different numbers can be made from some or all of the digits of the numbers 1, 3, 4, 5, 7, 8, and 9. If all 7 digits are used, the odd digits are all together and no digits are repeated. So when you're using all of them together, you can sort of use the same idea that you had in letters. 3, 4, 5, 7, 8, 9, none of them are being repeated. How many are odd? The odd ones are 3, 5, 7, and 9. There are 4 and 8 outside. The box acts as a dash. So I'm going to say the first is 3 factorial. Then I go inside the box. There are 4 numbers. So 4 factorial. Are any of them identical? No, none of them are identical. So divide by nothing. So I get 720. Yes. Part 2. It says the numbers made are even numbers between 3000 and 5000 and no digits are being repeated. So 4-digit numbers because 3000 to 5000. What can I start off with? I can start off with 3 and 4. I can't start off with 5. A number is going to be greater than 5000 then. So I have two C1 choice. In fact, let's first figure out if there are overlapping restrictions. There are restrictions in the last dash as well because I want them to be even numbers. So 4 and 8. So overlapping restrictions, I'm going to fix the first one. I'm going to make cases. I'm going to say that this can be 3 or this can be 4. If this is 3, n can have 4 and 8. If this was 4 at the start, then there is only 8 at the end. Okay, so 1C1 and 2C1. How many digits did I have in total? I had 6 digits in total, so I'm left with 2 dashes being filled. I'm left with 4 digits now, so 4C1 and 3C1. Okay, that gives me 24. 1C1 and 1C1. 4C1 and 3C1. Okay, same idea. Well, okay, let me check my calculations here a little. I missed something. Okay, what I missed is the number 1. Okay, so that presents a little bit of a problem. That's what I've done. 1, 3, 4, 5, 7, 8, 9. So there are 7 numbers. Um, 7 digits available. So this would be 4, this would be 5, and this would be 4. 40, 20. So a total of 60. I missed out on one of the numbers, which is why the answer is wrong. Part 3. The numbers are multiples of 5, which are less than 1000. So I want numbers that are less than 1000. And digits can be repeated now. That's so interesting. We've never seen a repeated digits question. Let's see what happens there. Um, it says the numbers are multiples of 5. So when you have multiples of 5, what can I say? Now, when they're less than 1,000, they can either be three-digit numbers or two-digit numbers or a one-digit number as well. If they are multiples of 5, then they should either end in 5 or 0. I don't have a 0. That's 1C1 choices here. But the interesting part of this question is that repetition is allowed, which means that I could have any number, 5 itself could also be repeated. So I have a total of 7C1. I'm going to say this is 7C1 into 7C1. Why? Because the digits are not getting reduced, the digits are being repeated. So I have a possibility of using the same digit over and over again. So this gives me 49. This one should also end in 5. And how many choices? 1C1 into 7C1. So that's 7 choices. So that's 1C1 choice. So 3-digit, 2-digit, and 1-digit numbers. How many in total? I have a total of 57 numbers. So digits questions are slightly more complicated. Will have to think about them. You will have to think about overlapping restrictions. Please, when you're doing the questions, make sure to filter them out mentally as to what category they fall into. Okay. It's easier to attempt a question when you know what category it's falling into. I will be back with another video, and I will see you in the next video with permutations in a line of different objects and so on. Okay. Thank you for watching.